Okay, dear students, please unmute yourself now. So here we are going to the power flow in the AC system. Okay, here we are having the two generators with having the loads which are connected load, and both are the interconnected. Okay, both are interconnected and transferring to the power supply to the load. Here generator 1 and here is a generator 2. Both generators having the different power flow. Okay, different power outputs. And if we are going to the transmission line, so this transmission line having the two transmission line. Here the impedance of the transmission, if we take, that is the X, and the power. Okay, due to the impedance, whatever the power flow is there. Okay, so apart from that, the power flow which is flowing the line, okay, due to the impedance, that is 2 beta. Okay, so here impedance is affect the power flow in a transmission line. So if we take the example as like, so if it is, if one simple line, so if we having the, suppose if you having the one line, that is of the, so resistor inductor. Okay, here resistor inductor, what happens whenever the resistor inductor having like AC network or DC network, what will happen? And so whatever the power flow is here, that will be effect on this power. Okay, so whatever the voltage is, okay, that voltage also drops due to the resistance and inductance. Okay, the current also is affected due to the inductance of the material or resistance of the metal. Okay, so here is the load. So load is whatever the it is there. Okay, so whatever the power is fully not affected to the any load. So here similarly in the transmission line, here we're having the two, so we're having the two generators, and here having the, it will both are interconnected. One transmission line having the X impedance, another transmission line having the 2X impedance. So here what here happened, so whatever the impedance is X is there, okay, that will having the 2 by 3rd power flow is flowing in that transmission. If it is impedance is high, means losses are high. Okay, that means resistance are increasing. So inductance, resistance, okay, that are increasing. So what will happen? The power flow will be decreased. So in that case, that is 1 by 3rd. So if it is impedance is high, so that whatever the power will be reversal. Okay, inversely proportional to that. So that's why we are going to reduce the that losses. Okay, so if you take the HV transmission, okay, here only we are taking the one simple AC circuit in a transmission. If you take this, okay, in coming to the same transmission line with interconnection, the HVDC line. here what will happen, here we have the thyristors. So in the HVDC there is nothing but, so we are having the thyristors is there. Okay, whatever line there, that is one of the AC, another one is there. So here we are having the both are DC, HVDC connections are. So here what will happen, so whatever the AC is there, okay, that will connect to the converters and it will transmission to the, by using the different thyristor controllers, and that will transfer to the through the line with the HVDC. Okay, that is in a DC transmission. So if a DC transmission only useful for the where higher line is, okay, whatever the distance with the two sectors, okay, so distance between the load and generating, if it is high, then only we are going for the HVDC line. So remaining times will go for the AC transmission line. So in this one, what will happen, whatever the AC is there, okay, so whatever the AC is, that will convert to the DC, and we'll have the 400 kV, 500 kV, 750 kV, okay, DC transmission will be done. Okay, and here what will happen due to that, so here whatever impedance there, that will be reduced. So resistance path will be also reduced, because here lines, whatever number of lines is also, number of conductors, that is also decreases. So here, so if it take, so if in the HVDC line can be used for the full thermal capacity, additive converter capacity. So we need this some capability limits there. Yeah, whatever the power flow is there. So power flow, we having the different factors will affect the, that is thermal ability, dielectrical maintenance, okay, weather condition, that will also affect in the transmission line parameters. So here whatever the stability is, so to make the, we have to maintain the same stability throughout the transmission line. Okay, so here if you take the DC transmission line, so whatever losses are there, that will be reduced, because we are going to convert the whatever the impedance is there, okay, that will also reduces, okay, due to the conversion process. Okay, because HVDC lines are mainly used for the longer transmission. For if we take the AC transmission line, it will use it for the, okay, so less, whatever the distance is there for the, from the load to generation station, that if a distance will be certain distance, if a higher distance we are if take, okay, then we go for the HVDC transmission. So in this app, if you take this one, so AC transmission and it having its losses, okay, that losses will be reduced in the HVDC, okay, like if we take impedance, okay, here impedance factor will be reduced. in the HDC line, because here conductors are reduced, number of conductors will be reduced, and whatever the factors will be having. Okay, so based on the voltage line, if we take the power factor will be power factor will be not affected in the due to the conversion. If we take the AC transmission, we have in the power factor. If we take here DC, so there is no power factor, right? Due to that, for longer transmission line, we are going for the HVDC. Okay. So if we take here HVDC having the variable phase angles, okay. So power control will be different. So here, so what they're doing to approach the whatever the transmission there. So DC transmission. So if in case to the AC transmission, if we take, so to avoid the such losses, whatever the impedance losses there, okay, that we have to avoid. So for that one, we need to going to adjust the phase angle, okay, whatever the power flow is. To control the power flow, we need the some control equipment. That control equipment is nothing but the that fax device. Okay, so here we are taking, right, this is for 2 by third. In this case here is a 1 by third due to the impedance, and here having 2x. So what will happen, the power flow will be reduced. So if you use whatever the power flow is reduced, that we have to inject in the transmission line. So whatever the reduced power flow is there, that we have to inject in the transmission line by using these fax devices. So here we have, by connecting the transmission line with the in series with the fax device, then we can easily achieve that power flow in a stability manner. Okay, if we take, so suppose here we are having the one example. So we are having, taking one example as with the how transmission lines are there with the with facts, without facts devices. Okay, so here we have the three generators A, B, C. Okay, three generators. So here we are having the lines. So what are the transmission line is there, that is having, and here we are having this. So what will happen, here we are having this, A is generating the 2000 megawatts, and B generator generating 1000 megawatts, and C is generating the 3000 megawatts. So here what we are doing, so 2000 megawatts is generated by the A, B. Okay, so B generator generating 1000 megawatts, C generator generating 1000. So here whatever the line is there, okay, if we take A to B transmission line, so it will having the 600 megawatt. Okay, and from B to C, that is a 1600 mega. So we need to transmit this transmission load cable. Okay, if it is load is there, so load we have to reduce. So in between the load is there, okay, that we have to avoid. So here it is a 14. So here we are having the impedance, that is a 10 ohms, 10 ohms, 5 ohms. So now coming to this network. So here what will happen, 1400 megawatts we have to transfer. So but so what will happen due to the 2000 megawatts. So if we will take 1400 megawatts flowing this watt and 600 megawatts flowing for total. Now coming to this one, so we will also same. So 1400, 1600, so if we take 1000. Okay, so by combining the 600 to this, so it will it must have to flow this load side. So here is the load is there, and here we have happen 2000 megawatts flowing through the here and 1000 megawatts flowing from the this side. So whatever the load is there, that is 3000 megawatts is we have to saturate this load. Okay, so here what will happen due to the impedance in the line. Okay, what happened, so due to the impedance in the line, so that affect the whatever that is there. So AB line, okay, whatever the AB line and BC line is there, so that will affect it. Okay, due to the impedance, if it is impedance is presented in this network. Okay, suppose if we take the BC network is there. Okay, so without having any fast devices, what will happen, high, so it have to provide the 600 megawatts to the this load. Okay, so without that, what will happen, high pressure will applied on this power plant. Okay, due to that, so if you using the control series capacitors in the line, okay, what will happen, so you can easily directly flow the 3000 megawatts. Okay, whatever the saturated load requirements, okay, that will be easy sharing by the done by the these two generators. So here having the generator A, generator B, here is the load. So at this situation what will happen, so here are using the this, if it take, okay, the in this case, so in this case we are doing system diagram with thyristor controller series cable. So we are having the thyristor controller with having the mine. Okay, so we are using the capacitor series cable. So what they, so whatever it is there, okay, impedance we are going to reducing that. So by reducing the impedance, what will happen, so for 1400 megawatts, it will go into, it is in the, that is 1750 megawatts are flowing. Okay, similarly from BC network, so BC network also it is flowing to the 50 megawatts are flowing. Okay, so here what happened, the load on the B, okay, the whatever the pressure is on the B is, that is reduced. Okay, from that one we can save the generator station. Okay, whatever the load I say, that we can easily reduce by using the fast devices. So thyristor control. So what will happen at the first case, here we are in the 2000 megawatts, and then 1000. So what is the load is that? That is 3000 megawatts we have to. So from this one, what will happen? 1000 megawatts. So it will, we have to flow this, that is high pressure is there. Okay, from the B. Okay, in this transmission. Here is the 1400. So if we are having through 2000 megawatts, okay, it will flow into the, due to the impedance, it will flow in the 1400. So by combining with the thyristor control in this line, what will happen? High amount of power is flowing in this transmission line. Okay, and whatever the pressure is there, okay, in this B
Sir, video vaya, sir.
so please log out and log in. Okay, please unmute and log out and log in. So here if you take the A, okay, so if you take the AC transmission line, okay, from A to C. Okay, here we take the students, please unmute. Suppose if we take the this transmission line, here we connect the one, here we connect the one capacitor. Okay, so here from the capacitor it is connected in series with the this transmission line. Here we are doing in this transmission line. So here whatever the power is there, okay, that we are improved by using the thyristor control. Okay, series capacitor. So here what they mean, so it will inject in the voltage due to the injecting voltage in this line. So here power is increasing. For that one, here B, whatever the B generator is, the load on the B generator is reduced. Okay, it is easily supply the load requirement to the BC line. Okay, so first case, what will happen? So at the BC transmission, okay, here we have the high amount of load is there. Okay, so high pressure is providing. Babu Vijay, hello.
Sir, ever convinced